said, thanks again for staying back late. My name is Sai Natarajan. I'm a product manager for the...
Please turn your mic on.
Yeah, my name is Sai Natarajan. I'm a product manager for the ASR 9000. Within ASR 9000 specifically, I work with Dennis on the data center interconnect technology, and that's what we're going to be talking about today. So as far as the presentation goes, I'll spend only probably about 5 to 10 minutes, give a brief overview on the value proposition of the ASR 9000 DCI solutions, specifically talk about how we have positioned ASR 9000 as the universal cloud gateway. The majority of the presentation today, Dennis will be talking about the different solutions overview in this space and what is the roadmap that we have going forward, what are the areas that we are investing in the data center interconnect space. ASR 9000, as you all know, started shipping about 4 years ago, and the product has continued to have a very strong acceptance and momentum with the customer base. Right now, we are close to about 1,600 unique customers for this platform, and we expect that to hit 1,700 by the end of this quarter. And also, we have deployed over 16,000 systems worldwide with this platform. The list here shows some of our public reference customers. Specifically, with respect to the data center space, we have continued to experience very strong acceptance and momentum as well. As you might know, within the data center customer space, we have 3 different customer segments that we are after with the ASR 9000 product line. The first one is the web and the OTT customers. These are the likes of the Facebook, the Googles, the Apples, and the Microsofts of the world. And with these customers, we are making very good inroads. In fact, we had our first big win with a web customer in last quarter, and the ASR 9000 is deployed in their production network. With other customers, we are in different phases of certification and product qualification, but the good news is there is very strong momentum. And when we talk about OTT customers in Europe, China, Russia, all these customers have already deployed ASR 9000 in the network. The second segment of customers are the enterprise data center customers. Again, here we have strong acceptance. So we have successful deployments with JP Morgan, Kaiser Permanente, a number of different healthcare providers. Again, these are enterprise customers which in some sense act like service providers because either they are like a San Francisco airport which is offering services to its different airlines, or a healthcare provider, service provider which is offering services to different hospitals. And the last segment is, of course, the cloud service providers. This, again, falls right into the realm of the service provider data center customers. And a lot of what Dennis will cover will focus on this customer segment. But the reality is we have successful deployments in all these different customer segments within the data center space. A brief recap of the product portfolio of ASR 9000. When the product was launched, it was launched with the 10-slot chassis and the 6-slot chassis. These two we have been shipping for almost 4 years now. When we started shipping them, they could support only up to 180 gigabit per second per slot. This was with our first generation of route switch processor. But end of 2011, we came out with our second generation of route switch processor, what we call as the Typhoon class of route switch processor and line cards. With that, the same chassis, we could scale up to 440 gigabit per second per slot. And then we also came out with our second generation of line cards, the Typhoon-based line cards, which included the high-density line cards, 24 by 10 gig and 36 by 10 gig line rate line cards, the 2 by 100 gig line cards. And we also have a number of different low-density modular line cards, which are available in 80 gig flavor and 160 gig flavor. Last year, we also started shipping our 2RU box, the ASR 9001, which is a pizza box style system, and it can support up to 120 gigabit per second of bandwidth. The ASR 9001, again, has had very good acceptance in our customer base. We just recently, about a couple of weeks ago, shipped the 1,000th unit of ASR 9001. Then middle of last year, we also started shipping the ASR 9922. This is the big brother chassis in our product family. This is a 20-slot chassis, and it supports up to 770 gigabit per second per slot. The good thing is, like, all these chassis can support all the same set of line cards. So whatever works in 9006 works in 9010 and works in 9922 as well. And we are not stopping here. These chassis, again, with the goal of providing investment protection to our customers, these chassis can scale much beyond what they support as well. So these two boxes can scale up to 880 gigabit per second per slot. So when we come out with our next generation of line cards and the next generation of switch fabric, again, the customers don't have to upgrade the chassis. Similarly, the 9922 can scale all the way up to 2 terabit per second per slot. This is a snapshot of the line cards that I talked about. One key message here is we are just not scaling the port density with these line cards, but we are also scaling the control plane scale with these line cards. And one of the reasons why we can do that is because of the distributed nature of the XOR operating system. Each one of these line cards have a line card CPU, and a lot of the control plane processing can be offloaded to these line cards. As a result, we can scale the control plane along with the port density, and this is one of the key differentiating factors for the ASR 9000, because when customers are deploying these line cards, they are typically trying to converge multiple services on the same line card, and they want a true multidimensional scale to be supported with these line cards. And next, I want to briefly talk about what is ASR 9000's positioning when it comes to the data center deployments. The primary position of ASR 9000 in this data center space is as a data center interconnect box, or what is also known as the DCI box. So this is the router that is sitting on top of your data center switches and is interconnecting the different data centers. So it forms the network infrastructure that makes multiple different physical data centers operate as one logical data center. The second common deployment that we see with our customers is where they want to collapse the data center core layer with the DCI layer, and which is also in the spine leaf architecture, that would be the border leaf layer. Again, we have a number of different customers who collapse these two layers, and ASR 9000 is again deployed in this collapsed layer. The third deployment that we see is where the customers collapse the WAN box, the data center WAN box, with the DCI box again. And this is again common amongst enterprise customers. Let us say you have a branch office or a corporate headquarters, you want WAN connectivity. At the same time, you have multiple different private data centers, enterprise data centers, and they want to have a router that can interconnect both the headquarters, the branch office, as well as the data centers. Again, ASR 9000 has a number of different deployments in this particular load. So again, what is exactly the value proposition for ASR 9000 when it comes to the DCI role? Why we believe ASR 9000 is the ultimate DCI router is because of these four different value propositions. And again, these value propositions match with some of the key requirements that our customers have when it comes to data center interconnect box. The first big requirement is the ability to support very high port density. Again, with the roadmap that I showed earlier of the products that we're shipping in the platform, we have industry leadership when it comes to port density. And with our next generation of line cards that we have in pipeline, we believe that we'll continue to maintain industry leadership in port density, whether it's 10 gig, 40 gig, or 100 gig. The second key differentiating factor is the unlimited service scale. Like I talked about earlier, the XR operating system allows us to do true multidimensional scale, which helps converge L2 and L3 services with very high scale numbers. The third key requirement is the ability to have a platform with flexibility and career class resiliency. Again, fundamentally, because this is a service provider box, it comes with the career class resiliency. And also the network processors in ASR 9000 allows us to do a number of different flexible configuration and programmability. And finally, the platform needs to support very good multi-tenancy with the ability to do VM mobility so that the workloads can be moved from one data center to another data center. Again, ASR 9000, in addition to the shipping solution that we have in the L2 DCI and L3 DCI space, we also have a number of new technologies that we are investing in this platform that are either in development or very close to FCS, which truly helps achieve the scalability and the mobility that is required in a data center interconnect solution. And finally, from a ASR 9000, like positioning as a universal cloud gateway, these are some of the key building blocks that helps us achieve the ASR 9000 positioning as a universal cloud gateway. The first one is the data center interconnect solution and the roadmap. I talked about some of the solutions, and Dennis will go into more details with the data center interconnect solutions roadmap that we are investing in the platform. The second key building block is the ability to integrate ASR 9000 with the data center fabric. And this is where we believe that is one of the key differentiation for the platform compared to, let us say, having a Juniper box as a DCI router. What we have done is the technology that we are investing in on the platform brings a tighter integration with the Nexus switches within the data center, and this is what helps our customers have a truly integrated end-to-end solution with the reduced total cost of ownership. Again, Dennis will talk about the different technologies that we are investing in to achieve this. Some of the other building blocks include the 100 gig interconnect. Again, more and more of our customers, driven by the very high bandwidth, demand for bandwidth driven by the video traffic, are looking at 100 gig links between the data center instead of having multiple 10 gig links which are bundled. And here is where, so it is not enough that you just have a 100 gig link, but it is also required to do this 100 gig link over long distances, which is to interconnect data centers. And here's another place where we are investing in technologies for IP plus optical integration on ASR 9000. Fundamentally, we view this as a two-box solution, but we are investing in technologies that bring tighter control plane integration between ASR 9000 and the ONS MSTP platforms to provide very good integrated 100 gig solutions to our customers. The other building block is the virtualized cloud services. ASR 9000 has today an integrated service module that is shipping with the platform, and we are also working on our next generation service module called the virtualized services module. And this, again, will help our cloud service provider customers offer virtualized services by running applications on the router. So instead of having applications run from a centralized data center, they can virtualize those applications and run it on ASR 9000 router, which is closer to the customer. And finally, ASR 9000 is also investing in the Cisco 1PK strategy. One of the big advantages of ASR 9000 is because it's network processor based, our hardware is already ready to support the Cisco 1PK. So all we need is just the software support, and we are already adding the software support on this platform. So ASR 9000 will be one of the lead platforms for demonstrating the Cisco 1PK and its advantages to our customers. And we already have a number of different interesting use cases that our service provider customers are interested in from having this two-way programmatic capability between the application and the ASR 9000. So with that, I'll hand it over to Dennis to talk more specifically about the solutions in the data center interconnection.
Hey, thanks, Sai. Good evening. My name is Dennis Kai, the TME on the ASR 9K. I will continue the ASR 9K session. I'll focus on the technical and the solution side. So at the first, I really appreciate you guys can stay here together with me. Okay. In the past 4 days, there's a lot of sessions, so you hear a lot of solutions stories. I think that's one of the good sides to be the last session, since I don't need to repeat this. So you have enough background information for the solution which I'm going to talk about. So let's have a quick refresh. What's the current data center design and the DCI design, and what are some of the challenges and shortcomings. So if you look at this picture, we have a typical 3-tier kind of data center design. And between the 7K and ASR 9K, we use VPC and MCLAC. Then you use VPOS for layer 2 DCIs. If you look at this particular design, this design has been certified as a Cisco CVD solution, as a Cisco VMDC solution. It has been widely deployed, so it works. But it does not mean it's a perfect solution. It has a lot of things which potentially could be improved. Let's look at the layer 2 at the first. Layer 2 DCI. So layer 2 DCI on the ASR 9K and the VPOS, we do have a huge control plane scale already, like 2 million MAC address, 64,000 bridge domains, 128,000 VLANs, which is really high numbers, okay, which is good. But one of the drawbacks of the VPOS is full mesh, okay? So this really means it depends how many data center sites you want to interconnect. If you only have like a couple of data centers, which is okay, but if it's over like 10 or 20 data centers, the number of the VPOS will increase exponentially, okay? So then it will cause a problem for the VPOS. I mean, that's the issue of the product itself of the VPOS, okay? That's for DCI. Now, if you look at the intra DC, we have the 4K VLAN limit, which is well known, okay? When you look at the redundancy side, we use VPC and MCLAC. So it supports active standby load balancing. And the convergency really depends on the scale. It could be a couple of seconds for 1,000 VLANs, okay? If you look at the packet forwarding, is really per VLAN-based packet forwarding, which is a traditional layer 2, right? When you compare with the layer 3, which is a per flow load balancing, it's not efficient. So those are kind of the issues which potentially could be solved by the next-gen technology, which is the EVPN technology. So I'm going to talk about that. That's from the layer 2 side. When you look at the layer 3, there's even more challenges there. If you still remember John Evanson talk about the VMDC solution, if you still remember the picture, they have like multiple BGP IS for the design. For each tenant, they have multiple VRF. So you do have the challenge for the VRF scale and also for the complex provisioning. So this also could be solved by optimized layer 3 routing. So this just kind of high-level overview of our current design and what the challenges we have from layer 2 side and from layer 3 side. Then how can we solve this? If you look at the market, there's like millions of solutions there, okay? And a lot of solutions still stay in the air, okay? So the solution I'm going to talk about is really going to the ground. So we're going to implement, okay, and it could be deployed for our customers. So we can look at this from three different directions. The number one is today most of the deployment is layer 2 based, And everybody knows layer 2 is not good, but it is deployed today. So how can we solve this issue of layer 2? That's kind of more like a natural extension, natural evolution, right? So that's the first focus, is to optimize layer 2 forwarding. The second one is, some people do not like layer 2. Some people don't like fabric path, don't like trail, which is okay. Let's use RP fabric and use VXLAN. We create a watch overlay for layer 2. So that's the second kind of evolution. So for the data center fabric. And the third one is optimize layer 3 routing. So when we talk about optimize layer 3 routing, and there's also a lot of solutions. So in the past couple of days, you heard about virtual CE routing, virtual PE routing. You may also heard about the WinChi, from DCBU for distributed PE routing and so on. So there's lots of options there. So what will be the solution on the AS9K side? So we can put all these potential optimization together and create an end-to-end solution for our customers. So certainly the first solution track is layer 2 centric. It's layer 2 optimized solutions. So we keep the layer 3 as same as before, but we optimize layer 2. So we can optimize layer 2 from DCI at first, use the EVPN and the PBB EVPN to replace VPLS. That's number one. So that particular solution has been EC'd already. The PBB EVPN will come out in August this year, and you can do the EFT from the May timeframe. So DCI might not be sufficient. Okay, within the data center, customer might move to the fabric path. So when you move to the fabric path, it makes sense. You have the integrated solution between the fabric path and the EVPN, so you can have end-to-end solutions for layer 2. So that's another kind of solution track. So that's from layer 2 perspective. The second solution track is really for layer 3, is watch overlay solutions. So we do the layer 3, but the layer 3 is built on top of the virtual network. So there's two kind of options. One is virtual CE routing, one is virtual PE routing. Okay, so I think you heard about this already, but I'm going to go to some details. What is required on the AS9K side? The virtual overlay solution maybe is okay for service provider data centers, but when you look at the enterprise data centers, might not be okay. Since enterprise, they focus on different things. For service provider, they're looking for really high kind of scale for the talents. Okay, the performance for each talent bandwidth might not be that high. But when you look at enterprise, the scale is not a big concern, but the performance might be even more important. So because of this reason, virtual overlay solution might not work well for some enterprise. So from Cisco point of view, we also need to work on the network integrated solutions. So like the WinChi solution. I think most of you may have heard about the WinChi solution. So for the WinChi solution, they have different technology for the data center fabric. Like in the phase 1, they use a fabric path. In the phase 2, they use a VXLAN. Okay. So you might see all these have different colors. Okay. So the green color means the particular solution, particular feature has been EC'd on the AS9K. For the orange color, which means right now it's really in the higher priority, and we try to get it in the 5.1.1, but the 5.1.1 release may not be sufficient. It may take another maybe 1 or 2 release to make the solution complete, but we're going to start from the 5.1.1. So what we're going to target is a VXLAN-based solution. So for both watch overlay as well as the WinChi, the network integrated solution. So that's our target. And you can see the red color is really the fabric path-based solution. So we're talking about the fabric path actually in the past 1.5 years. It really got a good traction from the customer side and from the field. But the problem for us is we don't have a solid business behind. Okay, so that's the reason we deprioritize fabric path below the VXLAN. But recently, we heard that more and more customers actually deploy fabric path, so it seems to come back. So if you do have the customers who are deploying fabric path and need AS9K support, please feel free to reach out to me and the side. Okay, but at this moment, we prioritize VXLAN higher than the fabric path, as you can see here. Okay. Any questions? So that's just kind of the overview of the strategy solution and for the IS-9K as a data center gateway. In the following couple of slides, it really goes through some of the details of the layer 2 solution, particularly is EVPN. Then we'll look at the solution for the optimized layer 3 for the watch overlay and also the Windshield solution. So what's IS-9K play there, and what's the key features behind? So before I'm talking about the EVPN, I want to see, how many people actually know the EVPN. Can you please show hands? Only like 10%, maybe 20%, okay. How many of you know VPLS? Okay, it's good. So EVPN is more like a natural evolution of the VPLS. If you look at it from the end user point of view, both EVPN and VPLS, they offer layer 2 VPN service, which means it's a layer 2 service. But when you look at the packet forwarding, it is quite different. For the VPLS, it's a traditional layer 2 forwarding or layer 2 bridging. You learn the MAC address in the data plan, and you forward the packet based on the MAC address table, right? In the MAC address table. If there's no MAC address, you're flooding, right? It's just like a traditional layer 2. That's for the VPLS. So because of this, you have all the drawback of the layer 2, like flooding, layer 2 loop, right? Per VLAN load balancing, and it's not scalable enough when you have a full mesh VPLS. So all those are like a drawback of traditional layer 2. So when you look at the EVPN, this is the fundamental part is for the MAC address. So we learn the MAC address in the control plan, and we advertise MAC through the BGP routing protocol, okay, which means that when we forward the packet, we look into the FIP table, just like a layer 3. So after this, all the packet forwarding will like a layer 3. Okay, so which means you have the full value of the layer 3, full advantage of the layer 3. You can support ECMP. You can support per flow load balancing. You don't have a pseudo wire anymore, which means you are scalable, just like the internet. So the EVPN is really the combination of the advantage of layer 2 and layer 3. So from the end user point of view, they still provide layer 2 service, which means you support VM mobility, just naturally we support it. And it support the application transparency. So for those applications rely on the layer 2, you can go with the EVPN. You still have all this advantage of the layer 2. But from the forwarding point of view, it's a layer 3. So you have all the advantage of the layer 3 as well. So it's a combination. Okay. So I want to use one particular example just to show you how the EVPN works. Just use one slide. Okay. But before that, how many of you know layer 3 VPN, how layer 3 VPN works? Okay, good. So if you look at this particular case, right, let's say you have two sides, which is a layer 3 VPN. What are you going to do? You use a BGP to advertise the customer routes, right? And then the packet forward is MPLS packet. You have two labels. Outer label is a VPN label. Outer label is OSP label. Inner is a VPN label. That's it. Now, when you look at the EVPN, we are doing exactly the same thing. We use BGP to advertise the MAC address. If you look at it here, the MAC address is tied together with the next hop, with the VPN labels. Everything is the same, just like a layer 3. The packet forward is MPLS. There's no pseudo wire. Okay. So you are really use a same kind of infrastructure you are built for both layer 2 VPN and layer 3 VPNs. Okay. So because of this, you have the full value of the layer 3. So we do have a lot of TOI slides. So if you want to know more details, you can go to our website. So there's a lot of TOI slides and the CLIs. So we're going to shipping this in August. Okay. So when we talk about EVPN, there's multiple variations. Okay. You have a PBB EVPN. You have a fabric path over the EVPN. You could have a trio over the EVPN. The reason we need multiple variations is very simple. So now for each VM's MAC address, which is translated into a BGP routes. So if you have millions of VM, which means you have millions of BGP routes. From the routing table point of view, which is okay. But if your VM is moved from one place to another place, just keep moving, right? You might cause a lot of BGP updates. So which means from a control plane point of view, it might not be that good. So because of this reason, we have different EVPN solutions. So the leading solution is called PBB EVPN. I mean, somebody heard of PBB, might be, oh, that's something not good. But the PBB in this case is only for the tunneling. We have a hierarchical for the MAC. So you have the backbone MAC, you have a customer MAC. So we only use BGP to advertise the backbone MAC address, which is the router's MAC address or switch's MAC address. But for the customer MAC address, we still keep it in a normal MAC address table. We still use the data plan MAC learning. Because on the IS-9K, we can learn the MAC address in 4 million PPS. So why, we have this capability, why not use it, right? So that's the reason the leading solution from us is PBB EVPNs. So they have the advantage of the MAC routing plus the data plan MAC learning together, okay? Now here's a real solution if you look at PBB EVPN. So within each data center, you could have a different layer 2 block, okay? Then you are interconnect all these layer 2 blocks through the IS-9K. For each block, you have 4K VLANs, and you can reuse the VLAN IDs across the different layer 2 islands. Since all these VLAN go to IS-9K, it could be translated, okay? So which means if you look at your entire data center, it could be 64K VLANs or bridge domains. So it is scalable, but just for each island, it is 4K, okay? When you go to different data centers, you use EVPN, so which is unlimited kind of scalable, okay? You can go to as many data centers as you can. It's just EVPN to provide the layer 2 extension between the data centers. So this is one of the solutions which is shipping in this August. Another potential solution, as I mentioned, is the Fabric Path. So when we have the Fabric Path, we could extend the Fabric Path domain to the IS-9K. Then on the IS-9K, we can do the Fabric Path to the EVPN seamlessly integration. So we can build end-to-end kind of MAC routing domain. So in this case, the IS-9K don't need to learn the MAC address of the VMs. The IS-9K only need to learn the MAC address of the switch. Okay, so it's much more scalable. Okay, again, this particular solution so far is not prioritized high on the roadmap because we need a solid business to prioritize it. Okay, so that's for the layer 2 side. Before we move to the layer 3, I just want to check if there's any questions. Yes.
So in the case of Fabric Path EVPN, so would we essentially take the ISIS underlying protocol and redistribute that into BGP? Is that how we achieve that?
Yes, exactly, yes.
Okay.
Yeah. So the local switch's MAC address or ID will be advertised to ISIS to IS-9K. IS-9K will redistribute into the BGP to the remote data center site. When you go to remote data center site, the BGP will advertise or redistribute the routes into the local ISIS domain.
Okay.
I mean, from the routing perspective, it's just like a traditional layer 3 design. You have BGP in the core, you have a RGP in each island. So exactly the same thing, yeah.
So that scale would potentially be even greater than PBB VPN, or just as great, right?
Oh yeah, this one it is better than the PBB VPN.
Okay.
Yeah, but you need more effort to develop this. Okay. Yeah.
So as far as the hardware, will we need to have any Fabric Path capable FPGA support, or?
No, we don't need it. Since the good thing for the IS-9K, we are the net NPU-based kind of a process forwarding. So it's a micro CPU-based. So we don't have hardware limitations. So the currently shipping hardware can support the Fabric Path, can support VXLAN, can support any potential features. Okay. So you don't have this kind of like a hardware limitation. This kind of things on the IS-9K. We don't have that. Yeah. Yes. From the configuration point of view, PBB EVPN and EVPN, they are pretty much identical. Okay. The only thing different for the PBB EVPN is when we implement the MAC address part is different. So for the PBB EVPN, it's more like we separate the edge and the core. So on the edge side, we learn the MAC address through the data plan in the hardware. And then in the core side, we use BGP to advertise. I mean, only that part is different. So, I mean, if you look at the configuration, everything else is similar. Is that your question? Okay. So now let's look at layer 3. So when we look at layer 3, there's, as I mentioned, there's a lot of options, okay? But fundamentally, there's two kind of options, okay? One is a centralized PE, one is a distributed PE. So there's two kind of routing, right? One is routing is for the customer themselves, they call CE routing. So for particular talents, they may have multiple segments. They need to integrate routing, okay? That's called CE routing. And that's one type of the layer 3 routing. Another type of the routing is the packet that goes through the WAN router and go to the internet or go to the customer client side or go to different data center. So that is called PE routing. So that the CE routing and the PE routing. So when we look at the solution, so one solution is a centralized PE. Another solution is distributed PE, okay? And within the for the centralized PE, so yesterday we talked about VMDC solution. One of the ways is to virtual CE routing. So you can push the CE routing all the way to the CSR on the virtual machine. So that's one of the solutions we are prioritized. So AS9K will actively participate in this solution. So when we look at the distributed PE routing, it could be virtual PE, could be a physical PE. For example, on the Vinci solution, we push the PE on the top of the rack, which is a physical PE. But we're also talking about the virtual PE, which means the PE routing is actually on the host, on the hypervisor, on the virtual machine. That's also a solution. But regardless of virtual PE or the physical PE, but on the AS9K side, it is the same thing. So on the AS9K side, what we need is interworking function, because on the northbound is MPLS, it's layer 3 VPN, but on the southbound is VXLAN. So we need that kind of interworking function on the AS9K gateway. Okay. So let's look at a little bit more details about this VMDC solution. It's a centralized PE with a virtual CE. What this means, okay? Yesterday, there's some session about this already, but I just want to share with you more details. The first one is from the CLI perspective, okay? CLI usually means can clarify a lot of things, okay? So in this case, let's say this is for a particular talent, right? They have two VXLANs, a green and a yellow. And if the packet is for layer 2, they just stay within the VXLAN. If they need customer routing between the VXLAN, it go to the CSR on the virtual machine. So if the packet needs to go to layer 3 VPN and go to the WAN, so the CE route will follow the packet or another VXLAN go to AS9K gateway. So there's a VXLAN between the CE and the PE that is only for the P to CE link, okay? And then you can run the traditional routing between the CE and the PE. Could be BGP, could be static, could be default, okay? So on this CSR, you can see it could have like 3 VXLAN interface, okay? The 2 interfaces for the real service. Another VXLAN interface is just for the connection between the PE and the CE. Okay. So if we look at the AS9K gateway, we need the interface VXLAN. We need to configure VRF, and potentially you need to configure BGP on this interface and some other features. Okay. Now here's the implementation on the AS9K. So this VXLAN interface is not something new on the AS9K. For the AS9K, we are building some common virtual service interface kind of infrastructure. We are doing this already for service providers. I don't know how many of you from the service provider space. If you are, you may have heard about the feature called pseudowire headend, okay, which is a PWE pseudowire. It's coming from service provider network, then terminate into AS9K, then go into the layer 3 VPN. Right? We have that feature already. Now we're using the similar infrastructure for the VXLAN. It's just encapsulation is different, but the infrastructure is the same. The packet coming could be VXLAN, could be NVGRE, could be PWE3 pseudowire, could be software GRE for SP Wi-Fi. It have a different encapsulation, but we decouple it and we put into the virtual interface. This virtual interface could be layer 3, could be layer 2. If it's a layer 2, I can put into a bridge domain, and from the bridge domain, I can go to BVI, I can go to VPOS, I can go to eVPN. So that's just kind of infrastructure we're building right now. And with this infrastructure, we can support layer 2, layer 3 VXLAN gateway. Make sense? Okay, any questions? Okay, now the second part is we're talking about is distributed PE model. For distributed PE model, the PE could be physical PE, could be virtual PE. So let's talk about Cisco Windchill solution at the first, which is a physical PE model. Okay, I think many of you know this already. It's more like a spine and a leaf kind of architecture. And from service provider point of view, right, spine is more like a P router, okay, and the leaf is more like a PE router. And the AS9K will play a role called a border leaf. And the border leaf and the DCI and WAN function could be consolidated together. So that's the value of the AS9K. So if you go with some other vendor's solution, you could have a separate, let's say, border leaf use 7K, then use, let's say, Juniper box as DCI. You need two separate boxes. But if you use AS9K, we can consolidate the border leaf and DCI together. Just use one box. Okay. So with this solution, you are running like a BGP control plan between all this leaf node, all these PE nodes. The BGP control plan is used to advertise the virtual machines routes or host routes. And within the data center, you use RGP, could be RSIS for the RP data center fabric. Okay. So from the AS9K point of view, we are working as an integrated border leaf. There is two kind of functions. One function on the southbound, we need to participate the Windchill RP fabric. So we need to support VXLAN. We need to run the BGP with a leaf as one function. Another function is on the northbound. So we need to integrate this VXLAN into the layer 3 VPN and into the layer 2 VPN. So on the AS9K side, as you can see, we have two major pieces. One is the data center fabric, one is the integration with the VPN side. So here's a data plan, some data plan details, how we're going to do for this integration. So this example is the traffic is from south to north. So the packet we receive is VXLAN in cap. So when we receive this, we just decap the packet, and we found the VXLAN ID. Then we're looking into some internal mapping table, is a VXLAN ID to VRF table. Then based on this information, we can look at the VRF FIP table. Then the packet will be MCOS in cap, and then we'll send to layer 3 VPN. So that's just from data plan overview. Okay, all this could be done without the configuration, interface VXLAN. So in this particular model, there's no interface VXLAN config. That's the key difference between the centralized PE model and the distributed PE model. With the centralized PE model, as I mentioned before, you do need to create interface VXLAN, right? You need to configure VRF, configure IP address. So you do have the challenge of the scale. So which means you need to support, if you need 8K talent, you need 8K interface VXLAN, you need 8K VRF, you may need 8K BGP sessions. But when we go to this distributed PE model, it's much more scalable. You don't need to create interface VXLAN. All this forwarding is done in the data path. Okay, it's much more scale. That's the big value of this distributed model, distributed PE model. Okay. So same thing for the north to southbound. So you receive the layer 3 VPN packet. Based on this VPN label, you can look at into different VXLAN ID. From the VXLAN ID, you can do the VXLAN in cap. Okay, so that's for the data plan. The next one is for the control plan. So the control plan could use a BGP, could use some external, let's say, controller, like SDN, okay? So this particular example is a BGP. And when we talk about the BGP, it could have a different design, like eBGP between the DCI and your SPNGN, or use iBGP end-to-end. But in any case, for this Vinci solution to work, the BGP update is a little bit different than the layer 3 VPN. So when you look at this format, right, this traditional VPN V4 routes, you have a RD, you have prefix, next hop, route target, and you have VPN label. But for the BGP route format, within the data center, you don't have the VPN label, but you have VXLAN ID. So it's only kind of small attribute change. So which means on the AS9K side, it's more like a very incremental effort to make it work for the BGP control plan perspective. But it could be a big effort on the Nexus side because when you look at the BGP feature, I mean AS9K is running ROS XR, which has been widely deployed in the SP. So we have the tons of the BGP features. But on the 7K side, the BGP feature is very minimal. So that's the reason it takes a lot of time for them to support this. But for us, it's more like incremental effort. Okay. So any questions? Yeah. So I think his question is, can we just transparently forward VXLAN into the eVPN or into the layer 3 VPN without doing this? That's about implementation, okay? Let's say if the data center is MCOS, VPN is also MCOS. So in this case, we just do the label swap, right? It's very simple, okay? Now, in this particular case, VXLAN ID is 24 bits, but the label is only 20 bits. We are talking about, the potential proposal. Let's say we only use the first 20 bits of the VXLAN for this kind of deployment. So potentially, we can optimize this data plan forwarding, just doing the more like a label swap. So we receive the VXLAN packet, we just replace it with MPLS labels. Potentially, we can do that. But as a first step, we need to doing the packet decap and then do the incap. Okay. Which is equal to both eVPN and the layer 3 VPN. For eVPN, same thing. So that's more like a PE on a physical switch, okay, which is a Cisco Vinci solution. There's another proposal is we need to compete with Juniper. Juniper solution is a virtual PE solution. So for the virtual PE solution, if you look at the AS9K gateway, which is the same thing, there's no difference, okay. But however, for the PE function, it will be distributed on the host, okay. So with this virtual PE solution, the control plan could be different. You can still use a BGP. For example, you have some virtual route reflector is running BGP. You could also just replace this with just SDN controller, okay? But regardless, on the AS9K side, the function is the same. So on the data plan, we do the interworking, okay? On the control plan side, we need to learn all these routes and then to advertise to the client side. So from our feature development point of view, we're just doing one time. We can work for both, okay? So that's just kind of a quick overview of the different solutions. What's the key component for each of the solutions? So I'm sure, we don't have enough time to go through all the details because, that's, I know you guys want to go, okay? But if you want to know something details, you can go to our website. We have a lot of detailed information there on the AS9K TME wiki page. Okay. Now here's a summary of the roadmap. So we have a 510, which is August this year, which has been EC'd already. Then we have 511, which is the end of this year. It is in the CC right now. And on the IS9K, we have a major release every 4 months. Okay, so when the release after 5.1.1 will be like April next year. So it's easy to calculate. Okay. So when you look at the solution, as I mentioned before, the PVB EVPN will be in the 5.10, and the EVPN itself will be later. Okay, since our leading solution is the PVB EVPN because it's a much more scalable solution than the EVPN itself. Okay. The fabric path again, it depends on the business case. So we may do it, may not do it. At this moment, the priority is lower than the VXLAN. Okay. Now for the VMDC solution and the Windshield Phase 2 solution, those two solutions right now we prioritize. We try to start from the 5.1.1. So it may take a couple of releases to be complete. So in the 5.1.1, initial focus is the layer 3 side. And then after 5.1.1, we'll have an integration with the EVPN for layer 2 side. Okay. So that's kind of a roadmap from solution perspective. Another roadmap is individual features. Okay. So we have 4.3.0, 4.3.1, 5.1.0, then 5.1.1. So in addition to these features, we do have some features in the middle. For example, in the 4.3.1, we have active load balancing for the multi-chassis lag. So it's kind of enhancement, okay, which is very useful for today's design. For today's design, you have to rely on the MC lag and VPC. So with this particular solution, you can use a VPC or you don't need a VPC, and it can give you a per VLAN active load balancing, and your convergency also is much better. Okay. And before the PVB EVPN, we also have the PVB VPLS. So for those customers who really like the VPLS, like the classic layer 2, they can use a PVB VPLS. Okay. And certainly, we also have the Lisp. I did not hear too much talking about Lisp this time, but we do have the Lisp on the roadmap as well. Starting from the 4.3.0 and the 4.3.1 and the 5.1.0. Okay. That's all I have. I seem ahead of time. Okay. Thank you.